I'm really pleased to be here. So, as Richard Clegg, and I should start with a disclaimer because this talk is a little bit about fraud. And I don't want to be a fraud. I'm probably not in the top 20 knowledgeable people about blockchain in this room, about blockchain-based technologies, because my expertise is on complex networks and temporal networks. And this is work I've done with various people over the years. Some of the collaborators there. I'll talk more about their roles. So there's three aims I had with this talk, and this is not in any sense an ordered list. I want to show you the analysis we're doing on these virtual trade networks, these networks, trading around dark markets, trading NFTs. It's work in progress. This is not yet published. I can probably learn a lot from people in this room about the systems I'm analysing. But really, my own research interest is temporal graphs. In particular, in this talk, we're looking at temporal motifs. And so that's the A1, aim A, and aim alpha. I did say they're not an ordered list. I want to show you this new research tool. So this tool, Raphtory, I'm honestly convinced, and I have no financial interest in the company, but I'm honestly convinced it's the best system you can use right now for analysing temporal networks. And I'll talk about that and how I think it can help in a lot of your research. This research is based around data sets. Some of them are publicly available, some of them are not. So what we've got is, from the company Chainalysis, they've shared with us in confidence Bitcoin trades centered around Alphabay and Hydra. Alphabay is one of the big dark markets. And we've got trades centered, I think, 2 hops back, but we can't share this data because they've done some entity resolution. You know a little bit about how Bitcoin works. Wallet addresses can spawn off and don't always trace back to one person. So a single individual can have many wallet addresses. Chainalysis' secret source that they don't reveal to us is tying those wallets to trading individuals. So our data set has some entity resolution, and that's why we're not allowed to share that data. The data set runs, it's getting a little bit longer than the 2 files for these things. It runs 2012 to 2021. We've also got NFT trades data that is public, and it's from a paper by Bancheli et al. Over at City, mapping the NFT revolution. Pretty well-known data set. There's quite a few NFT trades there, and that's data you can certainly, it's publicly available. There's a really common thing about all that data. It's a time-stamped set of exchange between users. One person is giving a thing to another person. The data connects 2 users. It's got time, a direction, and an amount, whether that amount is currency paid in the case of an NFT. So it's the most natural way for me to study that is as a temporal graph. There's a lot of things you can do with temporal graphs, and people tend to be a little bit conservative about what they do. They say, oh, it's a temporal graph, let's make some snapshots of it. And this is one thing that you can do. So you could, if these are your events at given times, node A connects to node B at this time, node C connects to node E at this time, node A to D here, and so on and so on. One thing that's going to help you is to study windows on that graph. And the system we're using allows you to do this really flexibly. So you center the window on some time t, give it a width tau, and form a graph from all the events that fall within there. Now you're studying only the trades that are in July, only the trades that are in the first hour on a Tuesday. As you see, that time resolution is actually quite critical. The other thing very important in the study of temporal graphs is temporal directionality. in the case of cryptocurrencies, we would think here naturally of something like payment analysis. So let's imagine we have some transactions at some time. So here's some potential transactions between wallets. I don't know if you can see that at the back. Tuesday, 5 p.m., Monday, 8 p.m., Thursday, 9 a.m. And if we know, and quite often in these systems, we do know that one of the transactions has some illegality associated with it, we might ask the question, where has that stolen money gone? You now need a system of tracing transactions forward in time. So this transaction by the potential hacker happens on Tuesday at 5 p.m. And if you're asking the question, where has their money gone to, it can only follow links that are temporally afterwards. So Tuesday at 5 p.m. cannot go to Monday at 8 p.m. It can go to Thursday at 9 a.m. It can go to Thursday at 11 a.m. But it cannot go to Tuesday at 4 p.m. This is why a lot of traditional approaches to temporal graphs, where you just take things as snapshots, are really going to fail to be able to deal with things like causality, things like the direction of time. If you sliced your graph down into snapshots, even if those snapshots are quite fine, you're still going to have this problem of painting things in the wrong direction in time. So, what I'd like to try and interest you in is the Raphtory software, in which I promise I have no commercial interest. This is not an advertisement feature. This was designed by my PhD student, Ben Steer. So in 2017, we had the idea, well, it's actually other C5 fields had the idea, let's get a project together and build a system from scratch that can be distributed, work at scale, and as temporal graphs as a first order member of its system. So it's designed from the start to ingest time-ordered data and to be able to work with queries over time. After the PhD, this was funded by the Alan Turing Institute for 3 years, and around about 2011, there's a small spin-out company, Motifs, who developed the open source version of Raphtory. So if you're interested in trying out this software, there is a company who are there to kind of help you, give you advice. And like I say, I don't myself have a commercial interest here, but I think you should use this software because I think it's the best software you can currently get to solve this problem. Almost nothing I'm going to present here could have been done with systems like NetworkX or GraphTool because it would run too slowly and it would take, you would have to do an awful lot of engineering to their system, put the time into it in the way that we require. So Raphtory required code written from the ground up to understand temporal networks. That was always the purpose of this piece of software. Let's have a quick look at the sort of thing it does. So it's designed to take a stream of updates with time. So in our system, this would be reading from a file, a list of NFT exchanges, or a list of Bitcoin transactions with a timestamp and an amount. Reads all of those in. You can add in data like, in this case, we've got a person with an occupation as a PhD student and later becoming a CTO. Ben made this slide, he's the CTO of the company. And somebody else, PhD student becoming a PDRA. And you can have changes of status, change of amount. It can deal with multiple links between the same two nodes at different times. And it takes this, what we call the graph builder, and the stream of events, and pushes them into partition managers, which can run across different cores of a CPU for scalability. And they can even, if we want, run it distributed across a number of different computers. We rarely find systems big enough that we require that. But this was designed to work on fairly large data sets. The stuff I'm doing today only has, I think the most is 63 million edges, which by the standards of what Raph can do isn't that big. What's its capability? It's very simple to ingest temporal graphs. It's specialized for that, so you can do it with specialized code. So I've given this as undergraduate projects, and those students have no problem getting up and running quickly. It's got built-in algorithms for a number of common tasks. So if you want shortest paths, if you want various community algorithms, or something like excuse me, various algorithms are all in there. You don't have to write them yourself. Plus, as I say, there's a company working with it. So if you've got some new algorithms, quite often they've got bounty boards and they're quite happy to work with you to put the algorithm you need. One of the things that as well is, if you think about that windowing, you might ask the question, well, what value of tau should I use? How should I have a day-long window, an hour-long window? How should I sweep the window across? It has built-in functions, so you can say in a single line, I would like to analyze windows that are a day long, I would like to shift them along by an hour, and I would like to do that for the whole of the data set, please. So it's got a lot of filtering. So, for example, filtering only temporally possible connections, like in the Cambridge example, that can be done automatically with single lines of code. Or you can say, I'm only interested in nodes matching a certain property. So we've been doing work on studying social hierarchies, and we can run the analysis separately on people who are chairs in the system and people who are regular members within the system. And it's really fast. It was written from the start to perform the analysis in parallel, just simply with the idea of going quickly on big data sets. So when I look at the experiments that we've done for some of the papers, if you're familiar with something like Network X or Graphpool, you'd be doing tens or hundreds of thousands of runs to get just one of the graphs that we produce. And quite often you find we can outperform custom systems. So when we start to look at temporal motifs, this system is finding trillions where the handwritten stuff in the literature is orders of magnitude, an order of magnitude fewer. Some of the things we've used Raphtory for, we've done social network analysis. We've done a paper on the alt-right network GAB and what we found there. The cryptocurrency and NFT analysis is something I'll talk about today. We've done some work on the company's house data set. So we have a scrape of companies' house directorships and a list of companies who've been given money by the UK government to work on COVID and supplying PPE and all that kind of thing. So we've done some analysis on that data. Quite recently, we've been analysing hierarchies and networks. Some of you might be familiar with the Internet Engineering Task Force. It's an organisation that's been going since the 80s. And they've kept quite very, very detailed records. They've got mailing lists running back since the 80s and detailed records of people in positions of seniority. So we've been able to look at hierarchies in social networks and how they change over time. We've been looking at some word semantic data, and this is only within quite a small group of people, our little group, actually, Mary, and the people at Commentary who work on it. The things I'm going to talk about today are wash trading. Probably everybody in this room already knows what wash trading is, but let's just go through. So NFTs, I guess you're all familiar with. I know people like to joke about NFTs and like, oh, just a waste of time. But honestly, if you've got kids using computer games and they're older than 12, they probably actually have valuable virtual property they're trading in some different way. So, so let's consider this. We've got some wallet that buys a particular NFT on a Monday for $50. Wallet B buys it on Tuesday for $100. Wallet D buys it on Wednesday for $250. And eventually it could even complete a full cycle and just pumping the price. Because a lot of these systems, there's automatic trading going on, and there's people just looking, what's the price of the NFT? What's the price of the NFT? What's the price of the NFT? And if they see it going consistently up, they put in a buy order. So we wash it around here. Somebody thinks, oh, it's gone 50, 100, 250, 450, 750. I guess I'll buy it. And they buy it. And they find suddenly there are no onward buyers. So the analysis I'm going to show is really very, very easy to do with the tool that we're using. But it can show some interesting things. So let's have a look at this. This is genuinely the journey of one NFT. And I defy anybody to say that this can possibly be honest trading. If this is honest trading, there must be a lot of buyer remorse going on, seller remorse rather. So it starts here. I don't know which of these happens first, but it's going to go up here. We bought there, we bought that, we bought back, back, down, back. Bought. And that's as far as we've seen that one going. And I can't think of any good reason why there's so many loops between that can possibly be representative of an honest trade in that system. What we can look at is
you're saying that the one in the middle is probably the interest in pumping the price of the NFT.
It could well be. I don't. It's hard to know. It's hard to know who is the cabal in here, but certainly somebody here is a dishonest actor. Possibly all of them are dishonest actors. We can't have any ground truth on that. I mean, I would certainly be very, very suspicious of that person there who was sold and rebought several different times. But what we can find is that these chains of these cycles of an NFT going around and coming back to the same person. Basically, the idea is you disguise it as well you can. Because you're hiding it in millions and millions of trades, if you can make these cycles long, maybe you won't be caught out. So some of the cycles we've found have gone up to a length of 200 hops before returning to the original buyer. I'm prepared to admit maybe there is a little bit of seller remorse and somebody coming back, but what we can see here is actually there's two fairly clear regimes. There's sort of short cycles with a long duration going for hundreds of days, but here this has gone around a cycle of 200, about 25 days, and there's this big kind of diagonal streak here indicating possibly the same kind of velocity of trading, where we're seeing a consistent pool of things being traded around 50, 100, 150 times within not very many days at all. If you view the data in the right way, it's blindingly obvious, but these cycles are hidden, as I said, in millions and millions of trades. The other thing we can see is comparing cycle duration to profit. So that's a profit in US dollars. So some very short cycles where people just try, I'll give it to you, you give me $60,000 more, it'll come back to me, let's see if we can get a real short cycle with a maximum profit. But actually, there's some other cycles with much longer duration and low profit there. So clearly people are trying different strategies to disguise what goes on. What do I conclude about the NFT market from it? It's worth saying right from the start, most of the things in our data set are not traded. Most of the things here are bought once and then left. So 4.7 million NFTs in this data set, and there's only 6.1 million traded. So most of the NFTs there have been bought and sat there. And that might just be a genuine desire to own that NFT. But it's clear that some of this activity is really suspicious. These extremely long cycles, and it's hard to imagine a lot of this is not completely automated. So we're getting these long cycles in a very short space of time, 200 ops coming back to the same person within a few weeks period. And I said, this is relatively simple analysis given the right tool. So you could reproduce and probably improve upon this analysis in a few weeks of work following the tutorials on the blogs on Motifs webpage. That's all I'm going to. That's most of what I'm going to say about NFTs. The other thing we've been doing is using temporal motifs, which I'm about to explain, to look at patterns within the dark web. So I suspect most people know more about the dark web than I do, but let's have a look at Alphabay, which is one of the largest and more famous, which basically, although legitimate things could be bought there, it mainly existed to sell things that you could not legitimately buy in that country. So Alphabay is a website like eBay that allows people to place adverts, buy and sell illicit goods and services, drugs, stolen data, guns, and the payment is made in Bitcoin. It also acts as an escrow service. So the transaction by default will sit there for 7 days until the customer says, I've got my goods, or and after 7 days, and if there's no complaint, 7 days, money will automatically go through. And we see that will become a bit important later, actually. This was shut down by Operation Bayonet in 2017, but many other dark markets popped up, and there's just a history of people migrating between these various marketplaces and sales moving between them. We've also got data on Hydra, which lasted a bit longer, but was still shut down. So what does this ecosystem look like? What kind of things do we see? So here is a user, Alphabay market, and a seller. Naomi, who did the animations on this. So the most obvious is marketplace transactions. The buyer puts money into escrow in the Alphabay marketplace where it sits. The seller hopefully transfers whatever illicit cargo is being sent. And if the buyer confirms that, Alphabay will release the coins to the seller, and they've successfully completed a transaction. There's also exchanges where people can give pounds, get Bitcoin, or very obviously give Bitcoins, get pounds back. More surprisingly, well, there's some peer-to-peer transactions which aren't an exchange or a marketplace, but just people who have come to know each other. And there's quite good evidence that around these marketplaces, users get to know each other outside the marketplace and just directly exchange between peers. Perhaps more surprisingly, if you've not come across this kind of thing before, is the mixer service, where a group of people want to obfuscate. People are painfully aware that companies and researchers are looking into these transactions and the transactions are public. So a mixer allows a lot of people to put their coins. Whoops! Oh goodness, what on earth happened there? A mixer allows a lot of people to put their coins into the pot, shuffle them around, all the coins come back out, and that you get back the same amount you've given, but now nobody's quite sure where the money originated. So if you're just a little bit paranoid, people are looking into your purchases, or you just want to make your transactions a bit more obscure, it's a good way to deal with it. The analysis tool we're going to use here is temporal motif. If you've not come across temporal motifs, what we're talking about is a very small subgraph that can characterize a certain pattern of behavior. So we're going to be talking about 3 linked temporal motifs with at most 3 nodes. So in this example, yellow transfers to red, then red transfers to yellow, then red transfers to blue. So there's some kind of exchange between these two, and then an exchange to a third party. We're going to set a delta, which is the maximum time these things must complete within. So, So if it happens at time 7, then 9, then 13, it's matched our criteria, and we can say that that's an example of that particular type of temporal motif. This one fails because the time is too large, it doesn't get within our delta 10. And this one fails because the order of the transactions is not correct. It's going from yellow to red, from red to blue, and then from red to yellow. That's not the same order of transactions. We can make a little catalogue of all the types of temporal motifs there are. It becomes a little bit jarring and hard to read, but we can classify them into different types of transactions. So over in the corner here, we have transactions that are owned between 2 individuals, either just 3 transactions between 2 individuals or various varieties of then A sends to B sends to A sends to B in different orderings. The light blue here are all outbound. So these light actually, the next slide will make this a bit different. Yeah. These motifs are a good initial paper is this Japanese paper, Motif and Temporal Networks, which we've taken some of the inspiration from. So if we look at these motifs on 3 edges, limiting them to one to complete within an hour, got pairwise trading. This is fanning out of money. So maybe this is an outbound pattern. Maybe it's a user making several purchases at once, or a mixer splitting a transaction, but that's the light blue there. Got these, which are pure inbound transactions. So maybe a vendor receiving lots of different purchases from different users, or some split transaction where the user is gaining the resources from a number of different wallets. And then different patterns. So this light blue is triangular motifs where somebody A sends to B, B sends to C, and A sends to C in some order so that the complete triangle. And then these remaining ones are all combinations that are a fan type pattern, but the direction isn't purely in or purely out. The first thing to answer is, do motifs tell us anything that just looking at the degree or just looking at the wallet balance doesn't tell us? So here we're just plotting the number of transactions for a particular node and the number of motifs. Note that these scales are all logarithmic. And what you can see is that a node with just a single transaction can have quite a large number of motifs, and there's huge variance here. So if we take, for example, 10 to the 3, a node which is involved with 1,000 separate transactions, that could have only a single motif, but it could have 10 to the 9, it could have 1 billion. All of them. All of them. Yes. Yeah. Well, all of them within the delta 10 or whatever delta we're using. In this case, we're using a delta of 1 hour. So we're restricting quite heavily. So these motifs these 3 nodes must sleep within an hour. So it is giving us very, very different information to simply looking at the degree. And also, if we look at the weighted degree, we could consider that to be the amount of money that's gone through that particular node. By the way, notice how these figures go. 10 to the 13, well, 10 to the 12 is that trillion, equivalent of $1 trillion US has been moved through this. Now, obviously, some of that is according to the fact that you can't really, if you're trying to draw down $1 trillion certainly things would go very badly with this ecosystem. But there is large amounts of money involved. It's interesting, there's a more or less a hard cut up here. There seems to be some kind of natural limit in the amount of trading you go through these. But the number of motifs, again, seems to have a huge variety of these nodes with quite a large weight tree. Some of them are hardly involved in motifs at all, others, a huge number of motifs that they're involved with. And this, the number of motifs is really very, very highly skewed. In the Alphabay data, the motif we see most often is the all out one. So 3 nodes all out. And we can see there's a small number of users with into the trillions of motifs there. So up at this top end, they're taking a huge amount of the weight of these motifs. When we look at the hydra data, there's something really quite interesting in this. By the way, this is a CCDF. So we're looking here at the proportion of nodes with this many or fewer. So that point indicates 10 to the minus 6 of the nodes have more than 10 to the 12 motifs. So if we look here, we can see these really striking vertical lines in the complementary CDF. What that's telling us is there's a huge number of nodes in this system involved in the same or more or less the same number of motifs. It's not perfect evidence, but to me that can only be evidence of some kind of mechanized automated behavior. I don't think for any other reason why the nodes would have nearly identical numbers of motifs in this trading network. Let's go and look at what the Alphabay data is showing us. As I said, the system is very, very efficient. So we're counting up to trillions. And in this 1 hour shot of the Alphabay data, we're seeing mainly these fan-out motifs, which is a very great surprise to us the first time we saw it. The most prevalent motif by a long way is 3 nodes all going outwards. And it's a long way, but also it's really worth noting the orders of magnitude this graph covers. Because over here, that's one of the triangle style motifs. It's really uncommon, 300,000 versus 6 trillion or 9.3 trillion. This is single direction pairwise transactions, so one person giving multiple times to another, and that's the next most common in the data set, but it is an order of magnitude below. And then these are all incoming motifs. And they're down in the billions, so they're 2 orders of magnitude below. Oh, yeah, yeah, it's a little bit hard to deal with that. I should kind of explain how to read, what I haven't done is explain how to read this properly. So if you want to try and reconstruct a motif, what you need to do is, let's take this one. This says back there, it says yellow goes to red first, blue goes to red second, and then blue goes to red third, and that gets us the motif in that place. I'll explain it, but I'm aware that this is a little off the screen. Frustratingly, it's on the screen here, so it'll be fine on the Zoom call. I'll skip over. We tested with the null model. But I'll skip over that for time reasons. But we found that the number of sorry? Oh, right, yeah. Yeah. Sure. Can you repeat the explanation? What, how do you read this plot? Oh, right. Okay. So to read this plot, if you want to say work out what this 6 trillion corresponds to, then it is first yellow to red, second yellow to blue, and then the third transaction is on this axis, yellow to blue. Yeah. In a paper, you can look back to the previous diagram, which is a dictionary motif. But, okay. One thing to say is the top users are completely diverse in their trading patterns. So this is our most prevalent user with the most motifs, which is up in the trillions. And these are all outbound motifs. These are almost fan-out motifs. They are mainly giving things away. When we look at the pattern of this user, it takes in from very few people. It doesn't store much value, and then it gives out a large number. We don't know what it is. We speculate it might be an on-ramp that is getting value from a small number of miners and distributing it to people with one currency. But we can't pin that down, unfortunately. But this other motif is almost purely outbound. So this one, 15 billion here, 3 billion here, and these motifs, these are almost purely inbound. So these motifs are almost purely incoming. One thing we really didn't expect, because as I said, this data set is centered on Alphabay, and Alphabay is the largest number of trades, the largest number of connections, and the largest number of users associated with it. But when it comes to motif counts, it doesn't make the top 10. So the node we expect to be the most important when we look at motif analysis was not the most important. And it's got a mixture, so it's quite high, some mixed motifs that are sometimes taken in, sometimes taken down. And that's consistent with this idea of it being an escrow service.
All the page and top five. Yes. What are you going in carrying? What is your?
Not quite sure. I understood your question.
Two nodes in the top five or top motif counts. I mean, on the left-hand side, you have all the nodes.
No, sorry, no. This is one node.
Okay.
Which is one node, our node with the most motifs.
Okay.
And it's really dominant.
And the other one, the other.
There's another node in the top five.
And what the difference? Where does it come from?
So basically, we're counting only the motifs that these individual nodes are involved in. So if we count only motifs involving this node, we get this pattern. Only motifs involving this node, we get this pattern. And only motifs involving Alphabay, we get this pattern. So that it's characterizing the trade that those individual nodes are involved in.
Okay, so the nodes look very different.
Very different, yeah.
And do you have any explanation or?
So in the case of the Alphabay, we know it is an escrow service. It's conveyancing. It's trading between different people. So that's consistent with it being in then out. If this is, say, an on-ramp where people give money and get crypto, then it's going to be gathered from a small number of people to give out to many people. So that will be consistent, but we can't actually identify that. And if it's all incoming, if it's all Bitcoin going in, could be somebody who's selling. Unfortunately, we have no way of tying these nodes back to original identities, or not yet anyway. If somebody in the room has ideas on how we might do that, and people like to do it.
Like the left one is like a cash dispenser, the middle one is a drug dealer, the third one is.
I mean, I tell you, you could, yeah, if you want to think of it like that, that's a cash machine, that's a drug dealer, and that's a shop.
Yeah.
I mean, that's consistent with the data we can see, yeah. That is very consistent with the data we see, yeah. Yeah. One thing to know, as I said, this is really, if you look at the Gini coefficient of these motifs, it's horrible. It's really unequal. So if we just remove the top 1%, look only at the motifs involving the 99%, we've gone from trillions down to millions. The 1% have loads of the motif count. So just to be clear, in this, we leave those highest 1% in the network, we just don't add their motif counts on. Yeah. So it's really dominated by that 1%.
So the 1% is like very different.
Yes, so this is the 1% removed. This is the 99%.
Yeah.
And most of this data is due to 1%.
Yeah.
Yeah, absolutely. Hydra shows more or less the same pattern as Alphabay. There's some differences. I'm at the risk of having far too many graphs. The NFT trade is very, very different. They're much more mixed. There's much more swapping in there. Somebody's pointed out to me, and I think this is an experiment we need to try. We're looking at this NFT trade in the direction that a trade is me giving you an NFT. But somebody else pointed out to me recently that actually you could look at that as I give you an NFT, it could also be looked at as you give me money. So maybe they look more similar to the reverse direction of trade, but it's much more diverse. There's much more types of motifs in here. If you look at the time scales, you find something really surprising with this motif analysis. So the red dotted line is the volume of trade, the total number of transactions in a given month. Alphabay was shut down, but continued, some interactions with it continued. But these motifs actually came up in 2016. There's some bulk of these associated with this entity that we don't quite know what it is. It's activity seems to spike, go back down again. And there's a very similar pattern for our hydra. So even though hydra is looking at the same system, it's centered on a different market. And we see here a huge spike at a much later period, which is the same pattern. This is something we absolutely cannot explain. I'm going to skip over that last graph in the interest of time. What do we learn from this motif analysis? Honestly, I think there's still a lot in these graphs that I myself don't understand. And maybe people in the room here have some of the answers for me. These motifs can show us distinctive patterns of trade, and they're almost certainly indicative of automated patterns of trade. They can highlight entities you might miss. The most important entities of these motifs were not the ones with the most transactions, but if you're not careful also, this motif-based analysis can be really misleading. So when we first looked at it, we said, oh look, this network is characterized by these particular outbound motifs, which is true, but they're mainly the product of a very, very small number of those. Once you remove those, it looks very, very different. And those trades are all confined to a very small period of time. So if you're not looking both at the individuals and at the time dimension, you're going to get a really misleading picture of what this network is doing. As I said, this is really preliminary work. We're moving towards a publication, but we're not there yet. Maybe there's people in this room who can help me, who can provide ideas or suggestions of what we're looking at. And finally, just my takeaway message. These temporal graphs are a really great tool to analyze any type of data when you've got timestamps. And I honestly believe that this Raphtory tool is the best thing you can use to analyze them. Temporal motifs have really given us some good insights into the nature of the trading networks that we're looking at, but you need both to look at time windows and to separate them out by individuals. Okay, thank you very much for your attention.